Today our topic is Tower of Hanoi. The Tower of Hanoi, also called the Tower of Bromba or the Lucas Tower, was invented by a French mathematician Edward Lucas in the 19th century. It is associated with the legend of a Hindu temple where the puzzle was supposedly used to increase the mental discipline of young priests. Tower of Hanoi is an example of application of stack. So, the Tower of Hanoi is a mathematical game or puzzle. It consists of three rods and a number of discs of different sizes. Here, there are three rods and number of discs. In our case, I am taking three discs here, which can be slide onto another rod. These three discs can be slide onto any other rod. Okay. The objective of the puzzle is to move the entire stack to another rod. So, the objective of this puzzle is to move these three discs into this rod by using the second rod. I have to move these three discs into the third rod by using second rod. So, what are the rules? Only one disc may be moved at a time. Each move consists of taking the upper disc from one of the rod, sliding it onto another rod on the top of the other disc that may already be present on that rod. And no disc may be placed on the top of the smaller disc. Three discs problem. Now let's try to imagine a scenario. Suppose we have a stack of three discs. Our job is to move this stack from source A here to destination C. How we can do this? Before we get there, let's imagine there is an intermediate point P that is an auxiliary rod. We can use B as a helper to finish this job. We are now ready to move on. Let's go through each of the steps. Move the first disc from A to C. Move the next disc from A to B. Move the first disc from C to B. So the logic is move the top n-1 disc from source to the auxiliary tower. Next, move the nth disc from A to C. So the logic is move the nth disc from source to destination tower. Next, move this disc from B to A. Move the top disc from B to A. Move next disc from B to C. B to C. Next, move from A to C. So the logic is move the n-1 disc from auxiliary tower to destination tower. In case of mode disc, transferring the top n-1 disc from source to auxiliary tower can again be taught as a fresh problem and can be solved in the same manner. So, see the pictorial representation first. 3 disc problem. First, move from A to C, then move from A to B, then move from C to B, then move from A to C, then move from B to A, then move from B to C, then move from A to C. So what are the steps? Three disks are there. Source tower is A, destination tower is C, and auxiliary tower is B. Next time, here our target is to, I have to move two disks where source tower is A, destination tower is B, and auxiliary tower is C. Next step is, I want to move one disk where source tower is A, destination tower is C, and auxiliary tower is B. Next, I want to send two disks where source tower is B, destination tower is C, and auxiliary tower is A. So these four steps are required. So what is the logic? How we can write the program? What should be the coding? Now see the discussion first. Function name is move. I am passing total number of disks. In our example, it is 3. So int n is 3, and 3 character variables S, D and V. S is for source tower, D is for destination tower, and V is for auxiliary tower. Now see how this function works. First time when I call move function, then I have to pass n, s, d, v. So what is n? N is 3, total number of disks. What is s? S is the source tower, that is A. What is d? D is the destination tower, that is C. And what is v? V is the auxiliary tower, that is B. Now see, if n equals to 1, is n is 1? No, n is 3. So come here, move n minus 1 is vd. Again call this function by passing the value n minus 1 is vd. What is n minus 1? N minus 1 is now 2. So call the function move. See how recursion works. Move n minus 1. N minus 1 means 2. S means what? S means here A. So A. What is V? V is B. So here it is B. And what is D? D is C. Here it is C. So now these values are this. Now if n equals to 1, is n is 1? No, n is not 1. So come to this else part. Move n minus 1 is vd. N minus 1 means now it is 1. What is s? S is A. What is v? V is C. And what is D? D is B. Now see, when I call this function again, first check if n equals to 1. Is n is 1? Yes, n is 1. Then you have to move from source to destination. So what is source? Source is A. What is destination? Destination is C. So first move is from, see this figure, A to C. Next this line. Move 1 is dv. So move, call the function move. It is 1. Then s, what is s? S is A. What is d? D is B. What is V? V is C. So move 1 A, B, C. Now come here. Again check if n equals to 1. Is n is 1? Yes, n is 1. Then move from source to destination. So source is A and destination is B. So second move is from A to B. Now this third line. Move n minus 1 VDS. What is n minus 1? N is 2. N minus 1 is 1. 1 VDS. V means what? V means C. D means what? D means B. And S means what? S means A. So move 1 CBA. So come here, again call this function. Check if n equals to 1. Yes, n is 1. Then move from source to destination. So source is now C and destination is now B. So move from source to destination, that is from C to B. Now after completion of this line, we are coming from where this line is called. So our second line is move 1 STV. So N is 3, S is A, D is C and V is B. This was the situation. So the second line is move 1 STV. So move 1, S is A, D is C and V is B. So move 1 ACB. So come here. If n equals to 1, is n is 1? Yes, n is 1. So move from source to destination, that is from A to C. Here it is A to C. Now the next line. Move n minus 1 VDS. N minus 1 means n is 3. So n minus 1 is 2. VDS. V is B, D is C and S is A. So move 2, n minus 1 means 2, V means B, D means C and S means A, that is 2BCA. So our new values are n is 2, S is B, D is C and V is A. So call the function move by this value. Now check if n equals to 1. No, here n equals to 2. So come here. Our first line is move n minus 1 SVD. So move n minus 1, that is 1. S means what? S means B. V means what? V means A. And D means what? D means C. That is move 1 BAC. Call this function. If n equals to 1, yes, n is 1. So there is one printf statement S to D. S to D means here S value is what? S value is B. And D value is what? D value is A. So it is B to A. Now the second line. Move 1 is TV. So call the function move by passing this value 1, S is B, D is C and V is A. That is move 1 BCA. Call this function. Now check if n equals to 1. Yes, n is 1. Then move from source to destination. That is from B to C. Now the third line. Move n minus 1 VDS. N minus 1 means n is 2, n minus 1 is 1. So 1 VDS means A, C, B. So move 1 ACB. Call this function again. Now check if n equals to 1. Yes, n equals to 1. Then move from source to destination, that is from A to C. So required steps to solve 3 disks problem are this. Now see the coding of Tower of Hanoi using recursive function. So this is our program. This is move function we already discussed, and this is main. In main there is one integer variable n. I take total number of rings. In our example it was 3, but you can take any number. Now call the function move by passing the total number of rings, that is n, and the source tower, that is A, the destination tower, that is C, and the auxiliary tower, that is B. Now when I run the program, enter total number of rings, so it is 3. So our required moves are this. Again I run this program with another input. Enter total number of rings. Say it is 5. So our required moves are this. So how many number of moves are required to solve this puzzle? If there are n number of discs, then 2 to the power n minus 1 number of moves are required to solve this puzzle. That is, in our case, if there are 3 discs, then 2 to the power 3 minus 1, that is 7 moves are required to solve this puzzle. Now some interesting fact about Tower of Hanoi. The Tower of Hanoi puzzle was invented by the French mathematician Edouard Lucas in 1883. There is a story about an ancient temple in India. Some say it's in Vietnam, hence name Hanoi. This temple has a large room with 3 towers surrounded by 64 golden discs. These discs are continuously moved by priests in the temple. According to a prophecy, when the last move of the puzzle is completed, the world will end. These priests acting on the prophecy follow the immutable rule by Lord Brahma of moving disc one at a time. Hence, this puzzle is often called Tower of Brahma puzzle. So, if there are 64 discs, then how many number of moves are required? It is 2 to the power 64 minus 1. These number of moves are required. And for each move, if 1 second is required for each move, then total these number of years are required to complete this task, to complete this puzzle. So, these numbers of years are required to destroy our world according to the prophecy. So this is your programming assignment. Write a C program to implement Tower of Hanoi puzzle. So these are your homework. Choose the correct option and answer me in the comment section what is the correct option. I am waiting for your reply. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.